Hey everyone, in the last episode we learned what machine learning really means. Today we are stepping deeper into supervised learning with a focus on classification algorithms, where AI doesn't just predict numbers but decides categories like spam versus not spam, pass versus fail, or dog versus cat. We'll cover decision trees and K nearest neighbors KNN, two of the most beginner friendly yet powerful algorithms in AI. Let's dive in. We will create a file called classification.py and then import libraries like NumPy, Pandas, Matplotlib, and import decision tree classifier from sklearn.tree, kneighbors classifier from sklearn.neighbors. From sklearn.matrices we'll import accuracy score, confusion matrix, and we will also load our dataset iris. Classification is a type of supervised learning where the goal is to assign items into categories. For example, spam or not spam, pass or fail, irisatosa, versicolor, and many more. Unlike regression, which predicts continuous numbers, classification predicts labels or classes. This dataset contains measurements of three species of iris flowers. It is one of the most famous datasets in machine learning. To load the dataset, I'm gonna write iris equal to load underscore iris x equal iris dot data and y equal iris dot target. I'm gonna now print feature names, target classes, and shape of data to the screen. Let's split our data into training and testing. I will run this program to check for errors. Cool, we are good to go. A decision tree works like a flowchart. It asks questions like, is petal length smaller than 2.5 and splits data based on answers until it reaches a decision. Let's build one. I will create a variable dt underscore model and then call decision tree classifier, and inside the parenthesis I'm gonna write random state equal to 42. Then we will predict, evaluate and visualize the tree. So we trained our decision tree, then predicted and evaluated it using accuracy score and confusion matrix. Then we visualized the tree. Let's run to see the output. The tree you see above shows how models make decisions step by step. Each split is based on the most important features at that point. And on the terminal you can see decision tree accuracy 1 and confusion matrix. KNN is even simpler. It doesn't create a model. Instead, when you give it a new data point, it looks at the k nearest neighbors and takes a vote on which class it belongs to. Let's see it in the code. To train our KNN model, we are going to create a variable KNN underscore model and then call kneighbors classifier. Inside the parenthesis, we are going to write n underscore neighbors equal to 3. Then we will train it and predict, then evaluate. KNN is great for small datasets like iris. You can adjust n neighbors to tone the accuracy. Let's visualize just two features, petal length and width, to see how KNN separates them. Let's first import listed color map from matplotlib.colors. As we only want to visualize just two features, we are going to create new variables, then train a simple KNN on these two features. With these lines of code, we created a mesh grid. Now we are going to plot them and use different colors like red, green, blue. And let's run this program and see what we are going to get. Changing this B to A. Okay, I wrote double R. It's a range, not a range. Let me save it. Cool. Each coloration shows how KNN separates classes. The boundaries between each colors are where AI decides. Fascinating, right? Let's build a quick real world style demo. Predict if a student is pass or fail based on their marks. So we will create a data set with scores of subject, maths and science, and also declare result. Then we are going to change this data set into a data frame using pandas. Let's encode the labels, then train the decision tree and predict new student. So we got student will fail. Simple yet powerful. AI now decides pass or fail based on past data. This is exactly how predictive systems work. And that wraps up today's episode. You've just learned two of the most important AI algorithms, decision trees and KNN, and even use them on real data. In the next episode, we'll move into unsupervised learning with K means clustering, where AI learns without any labels. If you found this helpful, hit like, comment, smart AI, and subscribe for the next episode. See you soon.